Hey, we're looking at how to convert decimals into fractions today. So we learned previously that rational numbers are a type of number that can be represented as a ratio of integers or a fraction. And we also saw that you could represent them as a fraction or as a decimal form. So there must be some way to sort of translate decimals into fractions and fractions into decimals. We're going to look at going from decimals to fractions today. And we saw that there are essentially two kinds of decimals that we might encounter. You might encounter finite or terminating decimals. You might also encounter infinitely long decimals that go on forever. We're going to see how to convert them back into fractions. So let's start out with the number 0.5. Now, you might recognize that this is equal to 1/2. Okay, but how do we get there? How do we show that 0.5 and 1/2 are going to be the same value? Well, what we can do is we can take this 0.5 and we're going to put it over 1, okay? The over 1 method here. So we've constructed a fraction. However, this fraction, it contains a decimal on top, and typically when we're using fractions, we want them to be constructed of integers, right? Rational numbers is going to be a ratio of integers. So we want to convert this 0.5 into an integer. That's going to require us to shift this decimal point over by 1 space, right? So how do we do that? Well, we're going to multiply it by 10. So we want to multiply this fraction by 10. But if we just multiply by 10, then we're going to change the value of 0.5. It's going to be 5, right? That's not the same as 0.5. So to preserve the value, we don't multiply by 10. Instead, we multiply by 1, okay? Because any number multiplied by 1 is the same number, right? 1 is the multiplicative identity. But instead of writing number 1 here like that, we're going to write it as 10 over 10. Because 10 over 10 is 1. And once we do that, look at what happens. We're going to get 0.5 times 10 on the top, that's 5, and 1 times 10 on the bottom, that's 10. So this fraction, 5 over 10, is the same as 0.5 over 1, which is the same as 0.5. And from here, we can actually simplify this further if we recognize that there's a common factor here, right? Now, 5 is a prime number, so I guess we could write this as 1 times 5. And 10 is the same as 2 times 5. So what we can do now is we can cancel out the 5s, and look at this, we get 1/2. That's what we always knew to be true. 1/2 is the same as 0.5. Okay, so this is the over 1 method. Just take your decimal, put it over the number 1, and then multiply by the appropriate power of 10 over whatever in order to move that decimal point over. And then you can simplify it, right? Once you get it in as a ratio of integers. Now, it's also possible to shortcut this a little bit. We can recognize that when we say this number in English, we could say 0.5, or we could say that since this is in the tenths place, we could say that this is 5/10. And when you write down 5/10, that's the same as 5/10, right? And then from here, we can simplify it over to 1/2, right? So you sort of shortcut right to the 5/10 here. You don't have to go through this whole multiplying by 10 over 10 kind of thing. Once you've done this a couple of times, you figure out what's going on, right? All right, let's try another example here. Let's try the number 0.35. Okay, 0.35. What's that going to be? Well, let's do the over 1 method. So we're going to take 0.35 and put it over the number 1. And then we have to multiply by 1. But we're going to do that as a power of 10. Now, in this case, we have to shift this decimal point over 2 spaces. So to do that, we have to multiply the top by 100, right? So we have to multiply by 100. And then to make this into a 1, we have to divide 100 by 100, right? So this is the same as multiplying the original number by 1. We're going to get on the top 35 and on the bottom 100. Okay, there you go. So we've constructed a fraction from this original decimal using the over 1 method. Now, can we simplify this? We can recognize that this ends in a 5 and this ends in a 0, which means both of them are divisible by 5, or 5 is a common factor of both of them. So if we were to do that, we can see that the top is the same as 5 times 7, and the bottom is the same as 5 times 20. So now we can actually cancel out these 5s, and thus this is equal to 7 over 20. Okay, so this 0.35 is the same as the fraction of 7 over 20. Can we then shortcut this? Sure, right? Recognize that this is the same as, well, this is the tenths place and this is the hundredths place. So this is the same as 35 hundredths, right? And once you have it in that form, well, now we can sort of shortcut over to this side, right? So we've already got this 35 over hundredths written out. Let's try one more example, a more difficult number maybe. How about the number 12.345? Okay, so 1, 2, 3, 4, 5. How are we going to do this? Doing the over 1 method. We're going to take this number, put it over 1. And now what are we going to multiply by? Well, we need to move this decimal 3 spots over, right? So to do that, we're going to have to multiply this by 1,000. And then we'll do this as 1,000 over 1,000 to not change the actual quantity amount. And we'll get 1, 2, 3, 4, 5 over 1,000. Okay, there we go. You could also simplify this. Recognize again, both numbers are divisible by 5. What are we going to get? We're actually going to get 2469 over 200. Okay, there we go. So this is the over 1 method. Allows us to essentially translate any finite or terminating decimal into a fraction. I want to show you another method we could use. This is the most common method to deal with this, but there is another method that'll come in handy a little bit later on. I'm going to call that the algebra method. Okay, let's try starting out again with a 0.5, just like before. Now the difference is I'm going to construct an equation here. I'm going to say that x, my unknown fraction, is equal to 0.5, and I want to find out what x is as a fraction, right? So how do we do this? Now that it's an equation, I am going to try and convert this 0.5 into an integer by multiplying both sides by 10. Right? And if I do that, then I'm going to have on the right-hand side, I'm going to have 5. And on the left-hand side, I'm going to have 10x. And now I can solve for x by dividing both sides by 10. And I see that x is going to be equal to 5 over 10. Simplifying that, I get 1/2. Okay, so there we go again. I'm showing you that 0.5 is equal to 1/2 using algebra, right? The algebra method here. Let's try a slightly more difficult number here. Let's say I've got the number 0.428, okay? Now, once again, I'm going to try and set this equal to x, and now I want to convert this into an integer. To do that, recognize I have to move this decimal point over 3 spaces, so that means I need to multiply by 1,000, right? So this is going to be multiplied by 1,000, and I have to do that to both sides in order to maintain the equality of this equation here. And that's going to tell me that I'm going to have 1,000x is equal to 428. And if I solve for x, divide both sides by 1,000, this side cancels out, and I'm going to see that now x is equal to 428 over 1,000. And you could probably simplify this as well. I believe if you simplify this, what are we going to get? We're going to get 107 over 250. So we can divide the top and bottom by 4. So this is going to be the simplified version here of 0.428 as a fraction using the algebra method. So that's how we can convert finite or terminating decimals into fractions. Typically, we won't use the algebra method. Usually, you'll use the over 1 method, recognize it's 5/10 or 428 thousandths, and just write that as a fraction directly and then simplify. But the algebra method will be useful when we look at infinite decimals. Okay, so let's take a look at that. We've kind of seen that infinite decimals come in two forms. You can have infinite decimals that are repeating. There's some repeating unit that occurs over and over again. Or you can have an infinite but non-repeating decimal where there's no discernible pattern in the numbers. We're going to look at repeating decimals here first. So you might be familiar with a certain example here. For example, 0.3 repeating. We know that this is the same as 1/3, right? And we know that from experience, typing 1/3 in the calculator, this comes up a lot. But what if we have a more general number here, something we're not familiar with right away? What if we had something like 0.252525 repeating, right? Or some kind of 0.25 with a bar over it, right? Let's say this is our infinite repeating decimal. How can we convert this into a fraction? Okay, well, if we try the over 1 method, it's not going to work, is it, right? So if you try to put 0.252525 repeating over 1, I mean, that's fine. But the whole point is then we have to multiply by some power of 10 in order to take this decimal and move it to the end. But notice, this is infinitely long. And so this n would have to be infinity. Right, so how do we do that? We're not going to get a reasonable answer here. Okay, so we're not going to do it this way. Let's try a better way. We're going to use the algebra method, but with a trick. Okay, with a trick that's going to save us. So once again, I'm going to say that x is equal to 0.25 repeating. Great. Okay, let's center this a little bit. Okay, so I'm going to say x is equal to 0.25 repeating. Now what I'm going to do is I'm going to multiply both sides. What I want to do is I want to capture a single repeating unit. Okay, I'm going to capture one repeating unit to the left-hand side of the decimal point. So I'm going to multiply both sides by 100. So I'm going to get 100x is equal to 25.2525 repeating. Okay, so that's 100x. Now, what are we going to do with this? Well, I've got essentially two equations now. I've got x equals something and 100x equals something, and I can use both of them. So I'm going to now get my original equation, and now I am going to subtract these two from each other. What do we get on the left-hand side? Well, we're going to get 99x. Okay, 99x. What do we get on the right-hand side? Well, notice what happens. This is going to cancel out. 0.25 repeating minus 0.25 repeating is 0, right? So nothing happens there. And then over here, we're just going to get 25. And so that's it. I essentially get an integer over here. And now I can just solve for x. I'm going to say that x must then be equal to 25 over 99. Pretty neat. Let's check if this actually works. All right, get my calculator out here. 25 divided by 99, 0.25 repeating. Okay, so that's how we can actually convert infinite but repeating decimals into fractions using the algebra method with a trick, right? The trick is that you're going to try and capture one single repeating unit to the left of the decimal sign. And so we have, in this case, the repeating unit is 2 digits long, so we want to multiply both sides by 100, and that's going to allow us to pull off the trick here. And this is a common trick in math. You're going to, essentially what we did is we took something that was very difficult to understand, and then we modified it a little bit and then compared it back to itself. Sort of like how the reflection of what it was canceled out the annoying, difficult part, and we were left with something reasonable that we could work with. All right, let's try another example, maybe a slightly more interesting number. Let's say we start out with the number 1.5197 repeating. Okay, so this is a slightly more interesting number. And I'm going to say that this is equal to x. Okay, so once again, I'm going to try and use my tricky algebra method to convert this arbitrary decimal into a fractional form. How do we do this? Well, what I want to do is I am going to want to capture this repeating unit and move it to the left of the decimal sign. But before I do that, I'm actually going to try and just move the decimal point over one space so that everything to the right of the decimal is just the repeating part. It's a little bit neater that way. You don't have to do it this way, but it's neater. So to do that, I need to move this over one point, one place, right? So I'm going to multiply both sides by 10. So I'm going to get 10x here is equal to 15.197197 repeating. Okay, so that's the first step. Now I'm going to try and do the next step and move this over an additional 3 spots. So to do that, I have to multiply both sides by 1,000. Okay, so I'm going to multiply 10 by 1,000. That's 10,000. And now over here, I'm going to get 15,197.197 repeating, just like that. Now that I've got it all set up nice and neat, I'm going to do my subtraction again. So this time I'm going to subtract this off right here. All right, so that's an X, and let's line up the decimal points. There we are. Let's do the subtraction. Okay, so on the left-hand side, what are we going to get? I believe we'll get 9,990x. And on the right-hand side, yep, this is all going to cancel out, right? And so let's see here. We're going to get 7 minus 5 is 2. 9 minus 1 is 8. And then we'll get 1, 5, 1. So here we go. 9,990x is equal to 15,182. Let's solve for x. That means x is going to be equal to 15,182 over 9,990. You can probably simplify this. Notice both of these numbers are even, so you can definitely, divide both of them at least by 2. But I don't care about that. Let's just try and check to see if this works. Okay, so 15,182 divided by 9,990. 1.5, 197, 197, 197 repeating. It worked. Okay, so the algebra method here works. You can convert any arbitrary, infinitely long decimal that has a repeating unit into a fraction using this method. Now, let's just talk a little bit about infinite but non-repeating decimal. So one example of an infinite non-repeating decimal that we looked at before was the square root of 2. If you try to put in the square root of 2 in your calculator, you get this really long number, 1.414, and it keeps on going forever. So here's the square root of 2. Now I said that because this was an infinite non-repeating decimal, it's impossible to convert this into a ratio of integers or a fraction. Why is that? Well, let's try it. Let's say we take this number, we try the over 1 method, right? So we're going to take this, and we're going to make a fraction out of it. We're going to put it over the number 1. Well, what do we do next? Well, the point is we want to try and move this decimal over until we get an integer. And in order to do that, you would have to multiply this by some power of 10 over itself. But because this is infinitely long, this n would have to be like infinity, and so that doesn't really help us. Multiplying by some, 10 to the power of infinities, that's a tough sell. So that's not going to work. What if we try the algebra method? Okay, the algebra method, we would take that same number and we would set it equal to x. And then what was the trick? Well, the trick was to multiply now both sides by some power of 10. And the point, again, was to capture a complete repeating unit. So if the repeating unit is, 3 digits long, then you would want to grab a chunk that's 3 digits long, and then you could, subtract and cancel out the infinitely repeating part. But the problem here is there is no repeating unit. You would have to keep moving on forever, and you would never capture any repeating unit. And so again, you're left with multiplying by some, 10 to the power of infinity. It doesn't work. And so this is why we say that you cannot convert this into a fraction or a rational number. And that's why we call it an irrational number. Okay, so irrational numbers cannot be converted into a ratio or fraction of integers. Okay. Okay, hopefully that helped. Now you know how to convert decimals into fractions. We can work with finite or terminating decimals, or we can work with infinitely long decimals as long as they have a repeating unit. If they don't, then that's an irrational number and cannot be converted into a fraction.